Okay, so binary. If you have any questions, any doubts, just feel free to disturb me, right? Anytime. So binary, binary is a number system, right? Which is used inside the computers and other electronic devices, digital devices. Digital means using discrete values. Discrete means some specific values. Digital doesn't mean that it's binary. It can be a set of fixed values. On the other hand, analog means varying values. There can be infinity amount of values, 1.1, 1.111, like that. But in digital, we have some fixed values. In digital, binary is a number system where we have only two states. And you know the two states, it's either 0 or 1. So here we are going to talk about this binary number system. And these binary numbers are represented inside the computer using electronic gadgets such as transistors, ICs, and microchips. And it's easy to represent binary using switches, because switch can have either on or off, right? Just like the switches in your house. And we can easily represent ones and zeros. So that's what these transistors and other electronic circuitry does inside the computer. And you know that 1 is represented as an electric current, and 0 is no electric current. So it sends pulses, right? Usually 1 is represented with 5 volts and 0 is 0 volts. So it's a set of pulses that we send inside the computer, right? And everything that you see inside the computer, in the computer, is represented using this binary digits, ones and zeros. Text to documents to pictures to everything, right? Characters, lowercase, uppercase, special, uh, special characters, everything, commands, everything is represented in binary. And binary uh, digits, when we use binary digits, we call it bits. 1 and 0 are called bits. So bit comes from binary digits, right? It's a combination of binary digits. A single bit can have two possibilities. That's either 1 or 0, right? What will happen if you increase the number of bits? Okay, so that is something that you should know, right? If you have 1 bit, you can have only two values, either 1 or 0. You can disturb me anytime, right? How do you get it? Since the base is 2 or binary, right? This comes from 2 to the power 1. This is the number of bits, right? So 2 to the power 1 is 2. So you have two variations, either 1 or 0. Now, if you increase the number of bits, okay, 2 bits, now it's going to be 2 to the power 2, and you're going to have how many? How many variations you're going to have? How many variations you're going to have? 2 to the power 2? 4. Right. What are these 4? You're going to have 0, 0, 0, 1, 1, 0, and 1, 1, 4. If you are going to have 3 bits, right, that's going to be 2 to the power 3, which is 8 combinations, right? I'm not going to write all those 8 combinations right here now. Let's look at it later on. So what you should understand here is, if you increase the number of bits, you can represent many variations, and that comes as powers of 2. Okay, so keep that in mind. Right, so that's what they say here, right? With 1 bit, there are 2 possible combinations. So if you are representing colors, they are referring this to colors, right? If you have 1 bit, you can have only two colors. Two colors, in the sense, for 1 you can represent a single color, right? If you are thinking of colors, right, representing colors using bits, single color, maybe white, maybe green, maybe yellow, and 0 can be used to represent black, right? So this is what is known as monochrome color. Monochrome. Mono means single, chrome means color, monocolor or single color. If you have 2 bits, if you have a 2-bit color system, you can represent 4 colors, right? 0 0 can be black. This can be another color. This can be another color. This can be another color. So when the number of bits increase, you can represent many number of colors. And you must have heard that there is a color scheme called true color. True color. In true color, we use 24 bits. 24 bits. That means you can represent 2 to the power 24 number of colors. That's huge. And this amount of colors means you're going to show the image which is almost same as the real picture. That's why it's called true color. Okay, right. Binary number system is based on 2 digits, that's 0 and 1. Okay, the number system we use is called denary. We used to call it decimal. That's wrong. I also learned from Cambridge syllabus. I mean, yes, Cambridge syllabus. Now it's there in Edexcel. It's called denary, base 10, right? In base 10, denary number system, how many numbers we have? How many numbers are there in denary? In binary, we have 2. In denary, Chamatka, Senara, Venu. In denary, how many we have? The
So
counting
is it the
numbers.
range of numbers?
I mean, the counting numbers that we normally use. The number
So
system we
infinite, right?
Pardon?
Infinite, right?
No, 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 no. What are the numbers we use in denary or base 10? Those are now infinite. We can get infinite by using those numbers, right? So how many numbers we have? We have only 10 numbers. That's 0 to 9. We can use 0 to 9, those 10 numbers, to create other numbers, infinite amount of numbers. So the denary number system has only 10 numbers, that's 0 to 9. Okay. And binary has only 2 numbers, that's 0 to 1, right? Okay, now if I ask you octal number system, octal means base 8. How many numbers are there? Octal numbers, that's base 8. Easy, no? If binary has 2, which is 0 to 1, if denary has 10, which is 0 to 9, what about octal? Octal means 8. It's going to have 8 numbers, that is 0 to 7. It's always 1 less than this base. Right, then we have a number system called hex or hexadecimal, right? Hexadecimal. We are not using octal here. We are going to learn binary, denary, and hexadecimal. In hexadecimal, how many? How many numbers are there? Come on, guys. Why? Why? Doesn't matter if it is wrong. Just tell me. In hexadecimal, how many numbers are there? Hex means
So
6.
16?
Yeah, that's right. It's 16, right? Hex means 6. Decimal means 10. So it's 16. And that's going to vary from 0 to 15. We'll talk about that later on, because when it comes to 15, this can be interpreted as 1 and 5 also. So, I don't know, maybe you have heard that. Okay, let me tell that here itself. And it's easy. Right? When it comes to this 0 to 15, 0 to 9 is no problem because it's a single digit. But when it comes to 10, 11, 12, 13, 14, and 15 in hexadecimal, these might be interpreted as 1 0, 1 1, 1 2, 1 3, 1 4, 1 5 also, not as 10, not as 11. So what we do is to represent these numbers, we use alphabetical letters. This is A, this is B, C, D, E, and F. So in hexadecimal, we have numbers from 0 to F. And remember, F is 15. Is that clear?
Yes, sir.
These are number systems. All right. So having that in mind, let's take binary and denary little forward, right? Okay, so if you take denary, you know, you have learned this in lower grades also. When you take a number like 3639, there's something called place value, right? And the first number, first digit to the right, which is 9, has a place value of 1. That digit has a place value of 1. Okay, and 3 has a place value of 10. 6 has a place value of 100. 3 has a place value of 1000. And how do we calculate these place values? It goes as powers of 10 because the base is 10 and it goes as powers of 10. You know the first value, the power, sorry about my coughing, the first value, the power is always 10 to the power, I mean, base to the power 0. So since it is 10, it's 10 to the power 0. And any numbers, 0th power is 1. So 10 to the power 0 is 1. Next is 10 to the power 1, 10 to the power 2, 10 to the power 3. That's how it goes. 10 to the power 4, right? And then how do you construct this number? You take the place value and multiply the digit by the place value. So 1 into 9 or 9 into 1, 3 into 10, right? There are 9 ones, 9 ones. There are 3 tens, there are 6 hundreds, there are 3 thousands. So 9 into 1 plus 3 into 10 plus 6 into 100 plus 3 into 1000. Altogether, you get 3639. That's clear, right? Is that clear? That's something you know already, right? Yes, sir. Okay. So when you go to the left, the place value increases, right? And it goes as powers of 10. Same thing applies to other number systems. If you take binary number system, it goes as powers of 2 because it's binary. Okay. Wait. Right. In binary number system, it goes as powers of 2. If you want me to explain again, let me know. Okay. Powers of 2. Right. Now take a byte. They have taken a byte. In byte, how many bits are there in a byte? In a byte, how many bits are there? Hey, come on, how many bits are there in a byte?
Sir, 8.
8 bits. Okay, 8 bits. Okay, so we have 8 bits here, right? 1, 1, 2, 3, 4, 5, 6, 7, 8. Right. Now, if you try to find out the place values, we have to start with from the right corner and goes as powers of 2. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. 8 bits. 2 to the power 0 is always 1. 2 to the power 1 is 2. 2 to the power 2 is 4. It's not 2 into 2, okay? 2 to the, I mean, yeah, it's 2 into 2. This one is not 2 into 3. It's 2 into 2 into 2. 2 to the power 3. 2 into 2 into 2 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 64, 128. Now, for this particular chapter, you need to remember this, right? You need to remember, you need to by heart this. And that's pretty easy, yeah? Because these values, they represent the memory also, right? For example, when you go for a pen drive, you have 16 GB pen drive, 8 GB pen drive, 4 GB RAM. So these values are quite familiar to you, right? You have 8-bit bus, 16-bit bus, 32-bit bus, right? You have 64-bit system, so you have 32-bit system. So these values are pretty easy to remember. Okay, so remember like this, it goes as powers of 2, and to get the next value, you can simply multiply by 2, right? So 1 multiplied by 2, 2, 2 multiplied by 2, 4, just like that. So easy, right? So 1, 2, 4, 8, 16, 32, 64, 128. Up to this is fine because we normally deal with 8 bits. But if you go beyond, it will be 256, it will be 512, 1024, 2048, 4096, right? You're just doubling the value. Okay, but you don't need to go up to that level, that far. Just 8 bits is fine. Understand? Is that clear? Is that clear?
Yes, sir.
Right. If you want me to explain again, let me know. Huh? Right. Okay, so that's the binary number system, right? The place values 2 to the power 0, 2 to the power 1, 2, 3, like that. And just remember these, because if you try to write the powers of 2 in the exam, you will waste a lot of time. Just remember the place values. Okay, right. So I'm going to share these. I'll upload the video so you can watch it anytime. Right. Converting binary into denary. Now, this is one of the most important questions that you will get. Conversions. Now, we saw the denary number system. We saw the binary number system. We know the place values. Now, how do we convert numbers between these two? Okay. How do you convert two number systems? Right. Now, for example, let's say, now, why do you want this? For example, inside the computer, you see ones and zeros. But if the computer is going to give us data as ones and zeros, let's say a number is going to give us ones and zeros, then we won't be able to understand what this number is, right? So it's very difficult for us to work with binary. So we need it to be converted into denary. So that's why we should know how this happens. Okay. The table can be used to convert binary number to a denary number. Denary equivalent of the binary number. This can be calculated as shown in the table below. Okay. So let me explain this to you. You know, we had to fight with the timer. So I know you might not like online classes, but can't help. That's why I'm recording the sessions and uploading, because literally we have only 1 week. Okay. So make sure that you follow these, attend the classes. I will have some more extra classes tomorrow or day after also. Make sure that you get the best, right? And let me know, right? That's why I created the WhatsApp groups. Let me know if you have any questions. You can do questions and share it in the WhatsApp group so I can check and give the feedback. You have no other option, right? Okay, what has happened here? we have this number 10101101. We want to find out what this number is representing. If we convert this into denary, since the number system we use is denary, we will be able to understand what this number is. And in fact, you already see that that's supposed to be 173 in denary. Now let's see how we calculate it. Simple, right? We take the place values of binary and we go on multiplying each binary digit by the place value. Simple as that, right? First we write the place values of each binary digit and we start multiplying the binary digit by the place value. And then we add them together. We add all of them together. Okay, so it goes like this. I will show you how it is done. First, I'm going to write the binary number 101 101 01101. Is that correct? 101 01101. Okay. Now you don't need to write this 2 to the powers. That's why I asked you to remember these place values. Okay. Then you write the place values just above this, right? This is 1, 2, 4, 8, 16, 32, 64, 128. It's so easy. Okay, got it? Understood? Salman, you just joined, no? Understood?
Yes, sir.
Okay, great. Now what we do is mentally, you multiply this, right? It's so easy because you have only binary numbers. It's either 1 or 0, right? If you had denary numbers or something like any other numbers, like other number system, then you are in trouble. Like if you had to multiply 128 by 6 or something, then you are in trouble. But this is so easy, right? There's 128. So you add 128. Plus, are there 64s? No 64s. So you don't need. Okay, no 64s. It's just 0, right? 0 into 64 is 0. 132. That's 132. No 16s. That's 1 8. That's 1 4. No 2s. That's 1 1. Add them together. 8 plus 2, 10, 18, 22, 23. 2 plus 2, 4 plus 3 is 7. And then 1. There you go. So easy, right? Super easy. Understood? Is that clear? All of you? Is that clear? Is that clear?
Yes, sir.
Chamatka?
Sir, can you do another example?
Yeah, I'll be taking another example. Yeah. Did you understand up to some extent?
Yes, sir.
Okay. Salman,
Yes, sir.
Venu, Venu. Understood? Okay. Let me take another example, right? Because they have given here. What are the denary equivalents of the following binary numbers? Okay. Let me take one more and give the other two to you, right? Okay, watch very carefully. This is activity 1 A. 0 0 0 0 1 1 1 0 0 1. Now you can notice that all these are 8 bits. Right? 1 2 3 4 5 6 7 8. So in this book, they are referring to 8-bit numbers, right? Throughout. It's super easy, right? Okay. What should you do? Now you should remember. Now, what are you going to do first? You are going to convert this binary number to denary. Okay. What should you remember? You should remember the place values. When you are converting binary to denary, you should remember the place values of binary. Place values of binary. And you know that it starts from 1 from the right corner. Okay, this is why you should remember the place values, right? You don't need to write 2 to the power 0 is 1, 2 to the power 1 is 2. No need. How do you start? 1. What is the place value of this? You guys tell me. 1. Tell me the place values. Tell me. On your mics and tell me. 1.
So 2,
1, 2,
4, 8,
4,
16,
8, 16,
32, 64, 1, 2.
32, 64, 1, 2, 8. Got it? Chamatka, got it?
Yes, sir.
It's easy. Okay, now what do? You multiply the place value with the binary digit and add them together. You can see it's 0 here. Multiplying 128 by 0 gives you 0, nothing. So you don't need to multiply. No need. That means there are no 128s. There are no 64s. There's 132. So you add 32. There's 116. Add 16. There's 1 8. Add 8. No 4s. No 2s. There's 1 1. Super easy, right? And then add them together. 6 plus 2, 8. 16. 17. 4. 5. 57, right? 32 plus 16 is 48. 48, 8, 56 plus 1 is 57. That's the answer. So this is denary 57. Now just imagine now if the computer process this in binary, it will process this in binary anyway. And if it gives out like this, we don't know what that is, right? Right. This is familiar to us because we deal with denary numbers. So that's why you need to know for this conversion. Binary to denary. Okay, I'll give you 5 minutes. Can you quickly do B and C and post it in the group? Take a photo and post it in the group.
Okay, sir.
Be clear? B and C. Okay, let's take this one. We are converting binary to denary, right? So first we'll write 1, 1, 0, 0, 0. 1 1 0 0 0 1 1 0 1 1 0. Okay. Those who are sending me the answers, I will check in a moment, right? All right, 1 2 3 4 5 6 7 8. What do? You write the positional value, right? Or the place value. 1 2 4 8 16 32 64 128. There's 128. So 128 plus 164. No 32s, no 16s, no 8s. 1 4, 1 2. Okay, and the answer 128, 64, 4, 2. Did you get 198 for B?
Yes.
Okay, great. And this one 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0, right? 1 2 3 4 5 6 7 8. So in the exam also you check whether you have 8 bits. Okay. Right, so this is 1 2 4 8 16 32 64 128. That's 128. No 64s, 132, no 16s, 1 8, no 4s, 1 2. 128, 32, 8, and 2. The high, the high. The high, the hard is the guy. Not that. Okay. 170? Is that correct? Did you get 170?
Yes, sir.
Okay, great. So hope you understood that. That's how you convert binary to denary. Any questions? No questions?
No, sir.
Okay, right. Next is converting denary to binary. The opposite, right? Right. This might be a little tricky, but there be an easy method also. Convert denary 230. Now, denary, when we say denary, we call this 213, right? To binary. Use the table and fill it as you calculate the equivalent. Okay. Okay. Let me show you this in a different way, right? Actually, there are like this is an easy method that they have shown here, but let me show you the normal method also, right? And then come to this one, right? Okay. So watch this carefully. Here we are converting denary to binary. Right. So normal method is this. Let's take an example. Let's say 65 denary is going to be converted to binary. Okay. You can also take a piece of paper or a book and do it along with me. 65 is going to be converted into binary because all these are, a little bit of, math questions. So these have to be done. You can't just watch this and do it, remember it, right? You have to do this. 65 is going to be converted into binary. So method 1 is this. This is the most common method, right? The normal method. We take 65 and we go on dividing this 65 by 2. Why 2? Because it's binary. We are converting into binary. We go on dividing 65 by 2. When we divide, we are going to put the remainder right in front of this. Okay. Well, now for 65, how many 2's are there? For this 3, for this 2, right? 2 into 32 is 64, right? 64 plus 1 is 65. So the remainder of this division is 32 and the remainder is 1. We put the remainder right in front of this. Understand? We divide 65 by 2, put the, what do you call this, quotient, right? Put the whole number here and the remainder right in front of it. Okay. Still, it is divisible by 2. So we go on dividing again by 2. There are 16 twos, and the remainder will be 0. Again, put the remainder right in front of it. Understand, all of you? Yes, sir. Still, we can divide. So we have to continue dividing by 2 until it is not further divisible by 2. So now 8 and the remainder is 0. It's so easy. Divide by 2 again. 4, remainder is 0. Still it can be divided. Divide by 2. 2 into 2, 4. Remainder is still 0. Still you can divide. 2, that's 1. And don't forget to put the remainder here. Remainder is going to be 0. Right? Many students, they forget to put this. The last division right here. The remainder they forget. This is important, right? So 2 into 1 is 2. The remainder is 0. Now you can see it's not further divisible by 2. Now we have divided it. Now we have got some ones and zeros. Now how do you write the answer? To write the answer, what we do is we go from bottom to top. Bottom to top to write the answer. That is 1. How many zeros? 1, 2, 3, 4, 5. 5 zeros and then 1. This is the answer. Did you understand? We take the denary number, we go on dividing it by 2 while putting the remainder right in front of the division. And we do this until it is not further divisible by 2. And the answer we write from bottom to top. That's the answer. Got it? Is that clear?
Yes, sir.
Yes, sir.
Now the method 2, right? Now method 2 is the easy method, but I would suggest that you do a couple of questions from this method and then move to this one. Right? In the exam, of course, you can use this. If they ask you to show how you did it, then use method 1. Otherwise, you can use method 2 to get the answer, right? So method 2, what we do is this. It's pretty easy. We write the positional values of binary. How do we start? 1, 2, 4, 8, 16, 32, 64, 128. Right? 8 bits. There are 8 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. Now what do you do is, our number is 65 now. Right? You try to put 65 into these slots. You are trying to put the amount in 65 into these slots. Do we have 65s? Sorry, do we have 128s in 65? Do you have 128s in 65? Do you? These are simple maths, okay? Do you have 128s in? No, right? So you put 0 there. Do you have 64s in 65? Do you have 64s in 65?
Yes.
Salman? Yes, we have. We have how many? We have 1, right? Okay. So we took 64 from 65. Keep deducting, right? Once you put ones there. So the balance is 1. Okay. That 1, where can we put? In that 1, we don't have 32s, right? 0. In that 1, we don't have 16s. 0. In that 1, we don't have 8s. 0. In that 1, we don't have 4s. 0. In that 1, we don't have 2s. 0. So in that 1, we have 1, 1. Put 1 there. We have got the answer. Easy, right? Okay. So when you're writing the answer, you don't need this leading 0. I can just write like 1. How many zeros? 5 zeros. And 1. Got it? Understood? Is that
Yes, sir.
clear? Yes. Excellent.
Yes, sir.
Okay. I'll finish it in 10 minutes, okay? Practice as much as possible. Okay. Now they have given 3 questions. Okay. I'll do the first one. You do the other 2, right? We'll do the first one using both methods, and the other 2 we'll do it using the easy method, right? Okay, let's take the first one. 69. What do? You go on dividing by 2. How many? 3. Tell me, how many 2s are there? 30. 30 what? Come on, this is so easy now. Divide 69 by 2. 30. Are you using the
34.
calculators? 30? 39, right?
34.
Oh, yeah,
34.
yeah. Sorry. My bad. 34, okay. 34, that's 68, right? Yeah, that's 68. And do you have any remainder?
Yes, sir.
1 remainder, right? Okay, 34, that's 17, right? 0, 2, 8, that's 16. Remainder is 1. Then 4, remainder is 0. 2, remainder is 0. And 1, and the remainder is 0. So this is the place where most of the students don't put the remainder, the last one. Okay, and also remember, if you have 2, that is represented in binary as 1 and 0. If you have 3, that is represented in binary in as 1 and 1. Okay, that's this is how it comes, because this is 1 and this is 2. So we have 1 2s, sorry, 2 1s, sorry, 1 2s. So it's 2. And here it's 1 and here it's 2. So we have 1 2s and 1 1s, that's 3. So just keep this in mind, right? 2 is 1 0, 3 is 1 1. So see, when it is 2, it's 1 0. Right? 2 is 1 0. Okay, now how do you write the answer? Bottom to top. That's 1, 3 zeros, 1 0 1. 1 0 0 0 1 0 1. That's the answer. Okay, now if you use the second method, how do you do it? You write the positional values 1, 2, 4, 8, 16, 32, 64, 128. As a habit, you use all 8 bits, right? Right. 69. Do we have 128? In 69, do we have 128? Do we have 120s in 69? No, right?
No, sir.
So it's 0. 0. Do you have 64s? Yes, there's 164. So 69 minus 64, you have balance 5. In 5, we don't have 32s, we don't have 16s, we don't have 8s, we have 1 4, and the balance is 1. And we don't have 2s in that one, and we have 1 1 in that. That's the answer. Easy, right? Okay, understood. Right. So
Yes, sir.
yeah, we can discard this leading zero. So the answer is 1 0 0 0 1 0 1. Okay, I'll leave this for homework, right? This B and C. Right. Do this. Uh, okay, since you just learned it, you do this using method 1 and method 2 both. Right? And you send it to me. I will correct and give it back to you. Okay. Right. So since the first class, shall we stop there? But I'm going to have it tomorrow and day after also. Otherwise, we won't be able to finish this.
So
And,
tomorrow what time?
anytime. If you have any commitments, just put a message in the group so that I can arrange my time. Right?
Okay, sir.
But even
Okay, sir.
if you miss, I will be recording and sharing it, so you don't need to worry about that, right? Okay. And later on, we have some difficult sections like sign and magnitude, whose complement, and especially arithmetics. The shifts, binary shifts, they are quite difficult, and they want us to finish the chapter. Okay, so don't miss any classes. Try to attend or at least refer to the video. Okay, right. Then see you. See you next time.
Okay, sir. Thank you, sir. Bye, sir.
Welcome.
Thank you, sir.
Thank you, sir. Bye, sir.